Requirements for this lecture are that you understand what an image is and that you've done a little bit of work with containers. So in this lecture, we're going to take a quick tour around Docker Hub and get to know a few of its basic features. And then we'll kind of discuss the difference between an official image and maybe other just as good images, and how to tell the difference between a good image and a bad image. And then I'll show a little bit around downloading images and how you can see the different tags that they'll use and the difference between an Alpine image and other image options. Okay, so you should have signed in to hub.docker.com. And when you sign in, your default homepage is your dashboard, which it will show you all of your repositories, public and private. Now, you're not going to have any yet, but you can see I have some here. They're all public. I have one private. But for now, let's go to the top and search Nginx. And what we'll get back is the search results of Docker Hub, and you'll see that there's a lot. Like, I could scroll for pages and pages, and one of the challenges is there's 15,000 images of Nginx. That's a lot. So I pretty much just use one or two. The official one right here, you'll see at the top, has 10 million plus pulls. So there's several characteristics to figuring out what's the right image. And like me, you're going to start using the images for your workflow that are related to what you do, and you're going to get used to specific ones. You're going to like specific ones. Typically, we always start with the official. Now, the official is going to be the only one with the word official actually below it. It will also be the only one where its name doesn't have a / in it. Now, when you and I create images on Docker Hub, we have to create them with our account name in front of them. So when you look at all these other ones, these are account names / image repository names. It might be actually an organization / Nginx or something like that. But the only ones that get to have just the name of the repo are considered official. And official images are ones that Docker Inc. actually has a team of people that help take care of them, ensure that they have quality documentation, that they're well tested, and that they're put together properly with Docker files that are obeying best practice rules. And they usually work with the official team of that software who actually makes it to ensure that it's doing all the things it should be doing. So I'm going to click on this one, and let's look at a couple of things about official repositories. Like I said before, you're often going to be using officials to start with, and then eventually you may find that you want to change it slightly or add a few things to it, and you'll make your own images. Official images are a great way to start. And one of the best things about official images is their documentation. They're always really great at documenting how to make them work, what options there might be, what environment variables, what's the default port, and so on. So back up at the top, you'll notice these versions. And versions are a common feature of official repositories. Now, you don't have to have versions in every image, but official ones do, because most open source software, there's always at least a few official versions out in the wild that are officially maintained and supported. And that's what we have here, is we have the mainline 1.11 for Nginx, and then we have what's considered the stable branch of Nginx, which is 1.10. And we can see the little name here. It says stable Jesse Dockerfile up here. All right, so let's break this down. 1.11.9, mainline, 1, 111, and latest. Those are all tags. And when we start talking about images, images aren't necessarily named. Images are tagged. And a version of an image can actually have more than one tag. And we're going to dive into this a little bit later when we start making our own images and we can play around with tagging. But for now, if I wanted to actually download that specific image, and you remember earlier that we actually already downloaded it. So if I do a docker image ls, you'll see the 3 images that we've worked with so far on my machine. And you see the tag that it says latest. Now, latest is a special tag, and it doesn't necessarily guarantee it's always the latest commit in the repository, but what it usually means is you're getting the latest version of this product. And in the official repositories, it's very well defined and consistent, so that if you didn't really care right now exactly what version you wanted, you just wanted the most current, then you could just say docker pull nginx, and it would download the latest. And you'll notice that it already knew I had it. It checked the SHA to make sure it matched the one from Docker Hub and says, hey, I've already got this image. It's up to date. What if I wanted to download Docker image version 1.11.9? So it's going to go check and see what it needs to do to download that image. And it turns out it doesn't need to do anything because it's the exact same version. And that's what this line means up here. I can refer to this main latest version right here by any of these tags. And the reason is if I just wanted to stay on the latest version of 1.0, whatever that might be for Nginx, I could just specify a 1. If I wanted to be more specific when I downloaded images and I wanted the most latest version of 1.11, then I could just type 1.11 like this and just leave out the .9, and it would download that one. But in my case, I actually specified the most specific of all, the 1.11.9, which shows the point release. And that was just to ensure that I got the exact version I wanted. So in your software, a best practice is when you're going to production and you're actually testing software that you're going to be using for others, you always want to specify the exact version. It's rare that you really want your software to update automatically. You usually want to control that process with some other DevOps tool. But when you're developing or just testing something locally, it's super easy with official images to just type in the name and just assume you're going to get the latest. So you'll notice here there's other ones. There's 1.11.9-Alpine, and these all have very similar names to the first one, but they all have the word Alpine in them. Now, we're going to get into base images and distributions later, but just for now, Alpine is actually a distribution of Linux that's very, very small. It's actually less than 5 meg in size, I believe. And this version will actually mean that it comes from a base image of Alpine, keeping it very small and light, whereas the default one, or the latest image, actually comes from Jessie, which is a Debian distribution. And it's a little larger in size, probably a little bit over 100 meg. And in fact, we can actually go over here and we can look. So Nginx, 182 meg right here. And if I want to download that exact version of the Alpine, I could say 1.11.9 Alpine, and then do Docker image ls. And you'll see that the Alpine version is actually only 54 meg, and the latest version is 182. And you'll also notice that the 3 versions that I downloaded all have the same image ID, because the image ID is based upon the cryptographic SHA of each image in Docker Hub. So this isn't actually 3 different copies of 128 meg images. It's actually a little deceiving. It's really just 3 tags of the exact same image ID, and it's only total taking up 182 meg, and these are just 2 other lines showing the same image ID with different tags associated to it. But enough about tags and versions for now. Let's check a few more things out in Docker Hub. So if I go back up to Nginx in the search bar and search for Nginx again, you'll see again that there's a lot of other options, and these can be made by anyone. You can create your own custom Nginx version, and because it's open source software and free to distribute, you can put it back up here and offer it up to the public. This is very similar to the model of GitHub, where they allow you to store open source software and you can fork other people's software and also offer it up. And the same thing goes here. You can use other people's images and download them, make them your own, re-upload them. And so if I ever want to consider not using an official repository, what I usually look for is the number of stars and the number of pulls. Because a popular repository, to me, tends to establish trust. Now, I always recommend you download and inspect the software before you use it, and look in their Docker file, and hopefully they'll have an open source repository that you can go look at exactly how they made that image. But A good indication is when you see things that have 5 million pulls on them and 945 stars. Clearly, there's something interesting about this package and why so many people are choosing it rather than using the official image. So you can come in here and look at their repository. You can actually see over on the right that he is linked to his GitHub repository where the actual open source software is that builds this image, so that you can go and inspect it and possibly download the actual source code outside of an image. But he clearly has done something with this Nginx image that makes it better than the official default. Okay, a couple more things. On the top bar, you'll see Explore, and Explorer kind of just gives you a summary of all the official images, and you can peruse through them. And trust me, there's a lot. In fact, in the resources for this section, you'll find a link to the actual list of official images. And under Library, this is where all the official images and their Docker files live. And you can see there's a lot. As a quick recap, in this lecture, we talked about Docker Hub and how it's similar to being the apt package manager for containers, and then how to recognize official images and how to use them. And then I helped you figure out how to determine a good public image from maybe a not so good one. And then a few tips about base images and how Alpine ones are typically smaller than their Debian counterparts. And so we're going to use these skills in the rest of this section.